In this video, we're going to talk about the distance formula. Section 9.1 has distance and midpoint formulas. In this first video, we'll talk about the distance formula. So, in order to talk about the distance formula, we're going to solve the problem of finding the distance between 2 points in the xy plane. So here I've marked 2 points in the xy plane. Here's the x-axis, the origin, and the y-axis. And the coordinates of the first point we'll say is x1, comma, y1. And the coordinates of the second point, x2, comma, y2. So what that means is, if we trace down the point here, this is x1, and if we trace this on the y-axis, this is y1. And if we trace down this point here, this is x2, and if we trace this point here, on the y-axis, this is y2. The main idea is to consider the segment that joins these 2 points and call the distance of, or the length of this line segment d, and then complete the triangle, the right triangle, by drawing a horizontal line from the first point and then a vertical line to the second point. So here we're talking about this triangle over here, this right triangle here. And using the Pythagorean theorem from geometry, we're going to, let's mark the right angle, it's right here. We're going to find d. And then we'll use that formula for the exercises that we're going to work on. Okay, so the distance horizontally between x1 and x2, this distance over here, is the absolute value of x2 minus x1. Next, the vertical distance here is the difference in the y's. So it's the absolute value of y2 minus y1. So now remember from geometry, the Pythagorean theorem, if we square each of these green sides and we square d, the sum equals d squared. So the Pythagorean theorem says that d squared is equal to the absolute value of x2 minus x1 squared plus y2 minus y1 squared. And because we're squaring these things, we really don't need the absolute value. So let me rewrite this with parentheses. x2 minus x1 squared plus y2 minus y1 squared. Now this isn't the distance, but it's the square distance. So in order for me to get the distance, I'm going to take the square root of the right side. So d is the square root of x2 minus x1 squared plus y2 minus y1 squared. And this is the main formula. This is called the distance formula. Okay, so let's take this out and see if we can calculate the distance between 2 points. So in this first problem, example, we would like to find the distance between the points 3, 8 and 0, 4. So I'm going to start by annotating these points. So 3, 8, I'll call that x1, y1, and I'll call this x2, y2. And so the distance between these 2 points, the distance, we'll call this d, is going to come from the square root formula we just established above. So the difference in the x's, so that's 0 minus 3, and that quantity squared, plus the difference in the y's, so 4 minus 8, and that quantity squared. Now remember to use the order of operations. So here, the square root comes last. The first thing we're going to do is the operations inside, so we have negative 3 squared plus negative 4 squared. Okay, so then we'll do the exponents. Negative 3 squared is 9, plus negative 4 squared is 16. So we have the square root of 25, and of course the square root of 25 is 5. So in this problem, the distance between those 2 points, d, is equal to 5. And I always like to draw a diagram to see what we just calculated. So let's go ahead and draw a diagram of these points. So let's say this is 1, 2, 3, 4. This is the origin, and we're looking at the x-axis. Then on the y-axis, we'll say this is 1, 2, 3, 4, 5, 6, 7, 8, and that's as high as we need to go. Then let's plot the first point. So the first point here is 3/8, so that's right here. And the next point is 0,4, so that's right here. All right, and the distance we just calculated is basically the distance, the length of the line segment that joins these. So this distance here is 5. That's the answer we got. That if you measure that distance is 5. Okay, let's try another example. Find the distance between the points -2, -5, and 4, 7. Okay, as before, we're going to mark these. This is x1, this is y1, this is x2, this is y2. And the distance formula gives the distance, d, gives us the square root. So we take the difference in the x's, so that's 4 minus -2 squared, plus the difference in the y's, 7 minus -5 squared. Okay, so let's compute the quantities in the parentheses. 4 minus -2 is 6, so 6 squared, plus 7 minus -5 is 12, so 12 squared. So here we get the square root of 36, 36 plus 144. And that gives us the square root of, let's see, 36, that's 180. Okay, now square root of 180 is not a perfect square, but we need to simplify this. So we can rewrite this as the square root of, let's think about it, 180, and we're trying to extract perfect squares from this as factors. So if you think about this a little bit, you will see that 180 is divisible by 9, and it's also divisible by 4. so it must be divisible by 36. And so 180 divisible by 36. 36 times 5. And the square root of 36 is 6. So here we have equals 6 square root of 5. So we found that the distance between these 2 points, D, is equal to 6 square root of 5. And if you punch this in the calculator, then you get an approximation. Let's approximate this rounded to 3 decimal places, so that's 13.416 approximately. Okay?